conductor, there is a current flowing, and due to that current, this is the magnetic field pattern due to this straight conductor. And if you want to find the direction of the magnetic field, then you have to apply the right hand rule. Okay,
Okay,
Maxwell
sir.
right hand thumb rule. Hmm? Hmm. Okay, so we did this in the last class. So now we will discuss the magnetic field pattern. When this wire, this is a straight wire AB, when this wire will become circular form, when this wire will become a circular form, so we will see the magnetic field due to that. So magnetic field pattern due to a circular wire, basically uh, this is a circular wire, you can see this circular wire, and this is a thin cardboard. Hmm. This is a thin cardboard, and this circular wire is embedded like this in this thin cardboard. Okay, this is C. C means this circular wire is there, and this circular wire is connected with a battery, positive terminal and negative terminal. Okay, so current will flow like this from the positive terminal to the negative terminal. Means in this circular wire, the current will flow. Here, the magnetic field lines or the pattern of the magnetic field will be somewhat different. When you will see, this is the wire now. When you will see near the wire, the concentric circles are there. Hmm? And when you will move here in this direction, the radius of the concentric these circles will increase. And at this point, the magnetic field line will be almost straight magnetic field line. Okay. Same is the case from this side. If you want to see here, these are the concentric circles, and when you will move from this side to this side, what will happen? The concentric circle size will increase, and in between, at the center of the wire, there will be straight magnetic field line. So what is this? This is a circular loop of wire carrying current. This is a circular current basically, and these are the magnetic field lines. So this type of magnetic field pattern is there due to a circular wire. So a circular wire fixed to a thin cardboard. So this is a thin cardboard. Why we have taken the cardboard? To show the magnetic field lines, we have taken the cardboard. So a circular wire fixed to a thin cardboard T. So T is the thin cardboard. Magnetic field lines near the wires are circular. Near the wires are circular. As we move away, concentric circles become bigger. So you can see the concentric, these are the concentric circles, and these becoming bigger. Okay. This circle is smaller, this is larger, this is far larger, this is another larger. At the center of the loop, magnetic field lines are straight. So here, this is the center of this loop. Here, the magnetic field line will be straight line. Okay, now due to this current carrying circular wire, what is will be the strength of magnetic field? I mean, on what factors the magnetic field strength due to a circular wire will depend. So the strength of the magnetic field produced by the circular loop depends upon number of turns of the wire. Number of turns. Uh, this is a wire of one turn. Okay, you can take a straight wire and you can make that circular. It will be one turn. After that, another turn, another turn. So there can be n number of turns. Okay, and if you will increase the number of turns, what will happen? The length of the wire will increase, obviously, and the amount of current will increase. Hmm. With respect to the turn, okay, it will means suppose you have increased number of turn of this wire to 3. So when you will increase uh, number of turn of this wire as 3, so what will happen? It will look like 3 circular wires are producing the magnetic field. 3 circular current carrying wires are producing the magnetic field. So that is why I am saying that the magnetic field strength will increase. And obviously, the more will be the amount of current in this wire, more will be the magnetic field produced by this wire. So the strength of the magnetic field produced by the circular loop, or loop means circular wire, depends on number of turns of the wire, current flowing in the wire, current flowing in this wire, and radius of the circular loop or the wire, depending upon the radius of circular loop of the wire. More you will increase the radius of the circular wire, less will be the magnetic field strength. Less will be the magnetic field strength. Okay. So this also in detail you will study in your 12th class if you have physics there. Okay, now after that, a current carrying circular loop or a wire behaves as a thin or disc type of magnet. For example, if we have a circular wire, okay, if we have a circular wire, so and in that circular wire, suppose the current is flowing. So basically, that circular wire will behave as the magnet, a thin magnet. Okay, like this is a circular wire, and in this circular wire, the current is flowing. So what will happen? This circular wire will behave as a magnet, and magnet have two poles, south pole and north pole. So two poles will develop. So now you can see here, if the current is in the clockwise direction in the circular wire, if suppose you are observing this wire, if you are observing this wire and you are observing that the current is in the clockwise direction, then this face of the wire will be south pole, and the opposite face, the face on the other side, will be the north pole. So north pole and south pole are there, means it is behaving as a thin small thin disc type of magnet. Now if the current is in the anti-clockwise direction, then it will behave as a north magnetic pole, and other side will be south magnetic pole, so anti-clockwise north pole, clockwise south pole. Okay, now questions are there. So this is very easy question again. You can see this question. The diagram given below represents the magnetic field caused by the current carrying conductor, which is, so this is the magnetic field pattern given, and this magnetic field pattern is due to a long straight wire, a circular wire, a solenoid, a short straight wire. Azaan, can you tell me?
Yes, sir.
What is the answer of this question? You can first see this, then you can tell easily. Circle, concentric circles, straight line, and this type of magnetic field pattern is due to a circular wire.
Yes.
Now see this. Basically, this is the pattern due to the circular wire. No?
Yes, sir.
So answer will be B. Another question. Which of the following correctly describes the magnetic field near a long straight wire? Near a long straight wire. The field consists of a straight line perpendicular to the wire. No. The field consists of around the straight conductor concentric circles are there. No? So basically D option will be correct. The field consists of concentric circles centered on wire. These are the magnetic field line or magnetic field pattern due to this wire, and these are the concentric circles, and center of these all concentric circle will lie on the wire. So basically the answer will be answer number means option D will be correct. Now this question, the direction of the current in the coil at one end of the electromagnet is clockwise. The end of the electromagnet will be, basically they are saying there is a coil, there is a coil like this. So the current in this coil is in the clockwise direction. So this face of the coil or this end of the coil will behave as south pole, north pole, or which pole? Clockwise. I told you na, anti-clockwise current, when there will be the anti-clockwise current, the face will become north pole. When the current will be clockwise, it will behave as a south pole. So answer will be south pole. Clockwise current na, south magnetic pole. Anti-clockwise current na, north magnetic pole. Okay. So now you should take the screenshot of this. Then we will discuss the next topic.
Done, sir.
Done. Okay. Take this screenshot.
Done, sir.
Okay.
Done, sir.
Just wait, just wait. Okay. Now you can take that.
Yes, already done.
Done? This
Yes,
one?
sir. Sir, this all I already done.
Okay. This one.
Done, sir.
Okay. So clockwise current, south pole, anti-clockwise current, north pole. Now next topic is the electromagnet. So basically electromagnet is a magnet due to the electricity. Electromagnet is a magnet. That magnet gets the magnetism or produces the magnetic field with the help of the electricity, or electricity means with the help of the current. So what is the basic fundamental of the electromagnet? We know that in a wire, if there will be the current, then due to that wire there will be the magnetic field. Okay, due to that, so on the basis of this we will manufacture or we will produce the electromagnet. So what we will do, we will wound the wire like this in helical form, and we will connect the ends of the wire with the battery, and the current will flow, and we will get magnetic field due to that. Okay, so electromagnet is this is the electromagnet. Basically this is the electromagnet and this is a wire. Okay, this is a conductor. This conductor is wounded on this, you can say, soft iron core. This is a soft iron core, basically a cylindrical rod of soft iron or iron, you can say. On this, the wire is wounded like this, and that wire will be of copper wire because copper has the maximum conductivity. And this wire is connected with a battery, and here is a switch. When you will close this switch, current will start flowing in the wire, and due to that what will happen? Magnetic field will produce, and due to that magnetic field, the soft iron core will get magnetized, and it will behave as an electromagnet. Means it will attract the iron pieces. So an electromagnet produces magnetic field by using current. An electromagnet produces magnetic field by using current. So here current is flowing in the wire. That is why this electromagnet is producing the magnetic field. These are temporary magnets and works on the magnetic effect of current. So these are temporary magnet. Temporary magnet means suppose this time this switch is closed and current is in this wire. So okay, and you have the iron nails. So this time this will attract the iron nails. This will attract the iron nail. Okay. When the current is flowing in this wire. Why? Because this time there is a magnetism in this magnet. When you will switch off, or you can say when you will open this switch, and current will become zero in this wire. So what will happen in that case? This magnet will loses the magnetism, and now it will not behave as a magnet. Means it will now not attract this iron piece or iron nail, you can say. So the example of the electromagnet is solenoid with soft iron core. Solenoid with soft iron core. You can say this is a solenoid. This is also a solenoid. Okay. Solenoid is a electromagnet. So example, solenoid with soft iron core. So what is an electromagnet? An electromagnet produces the magnetic field by using current. These are temporary magnets, works on the magnetic effect of current. After that, the next topic is solenoid. So what is solenoid? I told you that, see first this figure. This is the wire like this in the helical form, and a current is flowing in this wire. Due to that current, there is a magnetic field around this or in this solenoid. Okay, so this is the magnetic field pattern due to a solenoid. This is the magnetic field pattern due to a solenoid. Now you can see these magnetic field lines here like this, and inside this solenoid, the magnetic field lines are parallel straight lines, and parallel straight lines are representing the uniform magnetic field. Uniform magnetic field means at each and every point inside the solenoid you will get the same value of magnetic field. Okay, to increase the magnetism, okay, or to increase the magnetic field strength of the solenoid, you can insert a core in this. So it will be like this. It will be like this. Okay, so basically this is a solenoid with core, and this is a solenoid without core. This is a solenoid with core, this is a solenoid without core. Okay. Why we are introducing a core? Because when we will introduce the core, the magnetic field of this solenoid will increase. So see the magnetic field pattern due to the solenoid. So this type of pattern is there. Now see the magnetic field pattern in case of the bar magnet. This is a bar magnet and this is the magnetic field pattern. So both the magnetic fields are looking almost same, not same but almost same. So in case of the bar magnet and the solenoid, you can say almost same magnetic field pattern is there. So a solenoid is a long coil. Long coil, this is a coil, na? This is a coil. Long coil containing large number of turns of insulated copper wire. Okay, so this is a coil, this is one turn, second turn, third, fourth, fifth, sixth. A long coil of copper wire containing large number of turns. So this is a definition of solenoid. Or solenoid is a long coil containing large number of turns of insulated copper wire. Basically, okay, this is solenoid. And also solenoid is an electromagnet also. Hmm? Okay, after that, magnetic field produced by a current carrying solenoid is almost same as that of bar magnet. Fine. Hmm? See, magnetic field pattern due to a bar magnet and magnetic field pattern due to a solenoid. Hmm. So this is the due to solenoid. So magnetic field produced by a current carrying solenoid is almost same as that of bar magnet. After that, magnetic field line inside the solenoid are in the form of parallel straight line. So now see the magnetic field pattern due to a solenoid. Inside the solenoid, the magnetic field lines are parallel straight magnetic field lines. So these are parallel straight lines. Parallel straight lines. And these parallel straight lines representing the uniform magnetic field. Representing the uniform magnetic field. Uniform magnetic field. Uniform magnetic field here, 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 here. Everywhere the magnetic field is same. That is the meaning of the uniform. Uniform means same everywhere. This is solenoid with core. Solenoid you can say with core. And what is core? We are using core as soft, cylindrical soft iron rod. Soft iron rod. Soft iron rod is used as the core of the solenoid. And solenoid is an electromagnet. And electromagnets have temporary magnets. So Azaan, do you have idea why we are using the soft iron rod, not of steel or of any other material? Sorry, why we are using the core of soft iron? Why we are not using the rod of, you can say, steel? Hmm?
Sir, uh,
Hmm. Okay, you can try. Okay, I am telling, no problem. We are using the soft iron core na, because the motive is that to make the electromagnet in solenoid. Solenoid is what? Electromagnet. And we are using soft iron core in electromagnet. And electromagnet What is the use of the electromagnet? To perform the magnetism temporary. We want temporary magnetism. So to get the temporary magnetism, soft iron core is used. Why? Because once you will switch on the current, this soft iron rod will magnetize and it will behave as a magnet. When you will switch off the current, current in this will become zero, and suddenly after in very much less time, this solenoid coil, this solenoid core or this soft iron core will demagnetize also. But if you will take steel, so what will happen? Suppose this is the steel. So if you will take the steel rod as core, then in that case demagnetization is not easy. And if demagnetization is not easy, means that cannot be used for permanent magnets. Means for that cannot be used for electromagnet. That cannot be used for solenoid. Okay, so now we will discuss how the strength of the magnetic field due to this solenoid will depend or will change. Obviously, if you will increase the number of turns, the strength of the magnetic field will increase. Okay. And one more thing, you can see here inside the solenoid, the magnetic field lines are very close. Outside the solenoid, the magnetic field lines are far apart. You can say that here the magnetic field strength is more. Inside the solenoid, the magnetic field strength is more. Why? Because the magnetic field lines are close, and here the magnetic field is less. Why? Because the magnetic field lines are far apart as compared to the inside. So the strength of magnetic field produced by a solenoid carrying current depends upon the number of turns in the solenoid, depends upon the magnitude of the electric current. More amount of current will flow in this solenoid, more will be the magnetic field produced by this. Nature of core material used. Okay. So it will also depend upon the nature of the core material used. If you will use any other material, okay, different core material, the magnetic field produced by the solenoid will be different. For example, here if you are using a steel rod, then if you are using the steel core, if you are using the steel core, so the magnetic field will be somewhat less as compared to the soft iron rod or soft iron core. Why? Uh, with different core material, the magnetic field will be different because the magnetization and demagnetization will be different for different materials. So the use of the soft iron rod as a core increases the strength of the magnetic field. So nature of the so basically the strength of the magnetic field due to the solenoid carrying current is depending upon number of turns in the solenoid, magnitude of the electric current. Number third, nature of the core material used. Nature of the core material used. So now the magnetic field in a given region is uniform. This is the question. The magnetic field in a given region is uniform. Draw a diagram to represent it. So uniform magnetic field is represented by parallel lines, parallel straight lines like this. So basically this will be the answer. So parallel straight lines are there. We have seen inside the solenoid, the magnetic field lines are parallel straight lines. Means inside the solenoid, the magnetic field strength is uniform. Okay, so this question, what is an electromagnet? You can write an electromagnet is a magnet which produces the magnetism or magnetic field due to the electricity or due to the current. Describe the construction and the working of an electromagnet with the help of the label diagram. So for that, you have to use this diagram and you can draw it. That will be the construction. How you will write the working? You will first you will write the First you will write an electromagnet produces the magnetic field by using current. These are temporary magnet and work on the magnetic effect of current. Okay. And if you will want to explain the working in detail, then you will say here is a switch, here is a battery, wire is mounted on a soft iron core. When the switch is open, switch is closed, the current will start flowing, and due to that the magnetic field will produce, and the soft iron core will magnetize, and the magnetic field will be produced. Okay. After that, you can say when the switch will open, okay, this switch or this key will be open, then current will become zero. If current will become zero, the soft iron core will demagnetize and magnetic field will become zero. Explain why an electromagnet is called a temporary magnet. Because the working of electromagnet is depending upon the electric current, and when you will switch off the electric current, the magnetic field produced by the electromagnet will become zero. That is why it is a temporary magnet. It will remain until and unless there is a current on. Explain why the core of an electromagnet should be of soft iron, not of steel. So you can answer this like, in steel the demagnetization is difficult as compared to the soft iron. State the factors on which the strength of the electromagnet depends. Number one, number of turns. The amount of current. Second, the amount of current flowing. Third, the type of the core material used. And write some important uses of the electromagnet. So basically electromagnets are used in the transformer. Okay. Electromagnets are used in the transformers. Electromagnets are used, I think, in the medical purposes also. Okay. Okay, Azaan. So please take the screenshot.
Done, sir.
Okay.
Done, sir.
Hmm.
Done, sir.
Okay.
Done, sir. Done, sir.
Okay.
Done, sir.
So you can take the screenshot of this also. Done?
Yes, sir.
Can you do this question? Question number 37. This one.
Okay, sir.
There is a straight wire in current flowing when one wire is vertically upward. You have to tell the direction of the magnetic field in wire A and in wire B. And in wire B, the magnetic field is in the vertically In wire B, the current is vertically upward. In wire A, the current is vertically downward. So this is very easy. You will apply the right hand rule, and you will get the answer. Hmm? This is the answer of the question. If the current is upward, the direction of the magnetic field will be anti-clockwise. If the current is in the downward, the direction of the magnetic field will be clockwise. So what you will do, point your thumb, you will take your right hand, point your thumb in the direction of the current, and encircle your forefinger, encircle your finger. The sense of the curling of your finger or encircling of your finger will give the direction of the current. So upward current will give you the anti-clockwise direction of magnetic field, and downward current, vertically downward current will give you the clockwise. So you can say that in wire A, the current is vertically downward now. So the wire A, in wire A, the magnetic field will be anti-clockwise or clockwise? Hmm?
Sir, anti-clockwise.
No, in wire A, see,
Sir, wire A will be clockwise.
yeah, clockwise. And which rule we are using to find this direction?
Right hand thumb rule.
Right hand thumb rule. Name the rule which you have used to. It is Maxwell's right hand thumb rule. Okay, so now you can take the screenshot of this also.
Done, sir.
Okay. Now we will see the difference between the bar magnet and an electromagnet. So basically, bar magnet is the permanent magnet, and electromagnet is the temporary magnet. The magnetic field due to a bar magnet is less as compared to the electromagnet. Okay, and okay. So bar magnet is a permanent magnet, and electromagnet is a temporary magnet. Its magnetism is only for the duration of the current passing through it. So the magnetism of an electromagnet can be switched on or switched off as desired. A permanent magnet produces comparatively weak force of attraction. Means you can say the magnetic field due to a permanent magnet or a bar magnet is weak as compared to the electromagnet. So an electromagnet can produce very strong magnetic force. The strength of permanent magnet cannot be changed. We know this. The strength of the electromagnet can be changed by changing the number of turns in its coil or by changing the current passing through it. The north-south polarity of the permanent magnet is fixed and cannot be changed. The polarity of an electromagnet can be changed by changing the direction of the current in the coil. So basically, if in the coil the current will be anti-clockwise, then it will behave as a north pole, and other phase will behave as south pole. So polarity in case of the permanent or bar magnet we cannot change, but in case of the electromagnet we can change by changing the direction of the current. After this, so difference between the bar magnet and bar magnet and an electromagnet we did. After this, we will discuss force on a current carrying conductor in magnetic field. So if you will place a conductor carrying current in a magnetic field, it will experience a magnetic force. So basically, this is a magnet, north south pole. This is north pole and this is south pole. So basically, this is a magnet, and this magnet will produces a magnetic field, and this is the conductor. And suppose in this conductor there is a current flowing. So what will happen? This conductor will move upward. Why? Because this conductor will experience the magnetic force. Okay. So when a current carrying conductor placed in magnetic field, a magnetic force is exerted on the conductor. Due to that, the conductor can move. So this conductor will move upward. In this photograph, we can see a piece of aluminium foil that has been fixed between the pole of a strong magnet. When the current is passed through the foil, it is pushed upward away from the magnet. It happens due to the repulsion between the two magnetic fields, one from the magnet and one from the current. So basically, if in this conductor there will be the current, so due to that also there will be the one magnetic field, and this is the magnet, and due to this magnet there will be one magnetic field. So both the magnetic field here are repelling. Due to that, this conductor will be pushed upward. Means this conductor is experiences some magnetic force, you can say. So a current carrying conductor in magnetic field will experiences the force, and direction of this force is perpendicular to the direction of the current in the conductor, is also perpendicular to the direction of the magnetic field. Okay, so to find the direction of the magnetic force, there is a rule, that is Fleming's left hand rule. Fleming left hand rule. So arrange your left hand, or arrange the fingers of your left hand in this way: thumb, forefinger, and middle finger. In this way, uh, all these all the three fingers should be perpendicular to each other. These fingers should be mutually perpendicular. So this finger will tell you the direction of the magnetic field. This finger, means the forefinger, will tell you the direction of the magnetic field. This finger, middle finger, will tell you the direction of the current, and the thumb will give you the direction of the magnetic force. So adjust your left hand in such a way that the forefinger points in the direction of the magnetic field, center finger points in the direction of the current, then the direction of thumb will give you the direction of the magnetic force acting on the conductor. Okay, then take these screenshots.
Done, sir.
Okay.
Done, sir. Done.
Okay. So these two topics you have to do with the help of the NCERT, domestic electric circuit and electric fuse. With the help of NCERT, you should do it by yourself. Can you do that, Azaan? In
Oh,
NCERT, it is given. The diagram is also given,
yes, sir.
and and theory is also given. And you can take the help of some other book. If you have any other reference book, you can take help of that and you can do that by yourself. Okay. After that, dangers of electricity. So we know that what are the dangers of electricity. Due to the electricity, there can be the heat produced, and due to that heat produced, there can be the fire sometimes. There can be the electric shock sometimes. So these are some general dangers. If a person happens to touch the live wire, electric wire, he gets a severe electric shock. In some cases, the electric shock can even kill the person. First. Second, the short circuiting due to the damaged wiring or overloading of the circuit can cause the electric firing in the building. So what happens in case of the short circuiting? Na? When there is no proper wiring is there. So in that case, now what happens? In short circuiting, the current becomes maximum, and due to that, a lot of heat is produced. And maybe due to that heat, there can be the fire. And number third, the defects in the household wiring, like loose connections and defective switches, sockets and plugs can cause sparking and lead to fire. There can be sparking due to the poor electric circuits, you can say, and due to that also there may be the fires. Now, precautions in the use of the electricity. So if a person accidentally touches a live electric wire, or if an electric fire starts in the house, the main switch should be turned off at once so as to cut off electricity supply. This will prevent the fire from the spreading. So this is very easy to understand. If suppose due to the electricity, if there is any fault, means if there is, suppose I am sitting here right now, there is a fault of electricity, and due to that there is sparking here. Okay, or you can say there is little bit of firing also due to that burning of burning due to electricity or electric fault or electric spark. So what I will do, I will switch off the main uh, there is one uh, main electric supply. Okay, there is main electric supply for each and every home. Okay, so we will switch off the electricity from there, and elect and after that we can see the all of the electric devices will be switched off, because okay, you are switching off the main uh, what you can say, you are switching off the electricity from the main board. Okay, after that, the person who happens to touch the live electric wire should be provided an insulated support of wood, plastic or rubber. If suppose sometimes there can be the condition that someone have to touch the live wire. So if he is doing so, so he should wear the gloves of rubber or plastic. Okay, we should never try to pull away the person who is in contact with live wire, otherwise we will also get a shock. So human body is also the conductor of the electricity. So if he will get a shock, if you are touching that person, you will also get the electric shock. All electrical appliances like electric iron, cooler, refrigerator should be earth connection to save ourselves from the risk of electric shock. Even if the earth connection is there, we should avoid touching the metal body of the electric appliances when it is on. So basically what happens now in the electrical appliances like iron, okay, electric iron, cooler and refrigerator, sometimes we get electric shock, and the reason is that uh, if those devices are not earthed. Okay, earthed means when you will earth that device, so all the charge from that device will be flow to the earth. Okay, and there will be no electric shock. Okay, so that is why the earth wire, we use the earth wiring. Okay, so 3 you can write it. They can ask you in exam, so you can write 3. Okay, Azaan, so have you taken the, okay. Okay, this is the question. So basically in this question, it is given that a stream of positively charged particle, alpha particle moving towards west, is deflected towards north by the magnetic field, the direction of the magnetic force. So basically alpha particles are there. Alpha particles are positively charged particle. They are moving towards west. They are moving towards west, and force on means they are deflected towards north, means the force on the charged particles will be towards north. So they are asking what is the direction of the magnetic field. First of all, we know force, current, and the magnetic field are mutually perpendicular. So obviously the direction will be either upward or either downward. Hmm? For finding the upward and downward, we will use the right hand rule. Okay, like this. Thumb should be in the direction of the force. Okay, thumb should be in the direction of the force, and the central finger should be in the direction of the current, like this. So you will get the direction of the magnetic field. See, upward direction you are getting. Thumb towards force. This uh, middle finger towards the current, and this is representing the direction of the magnetic field. So magnetic field direction will be upward. Azaan, so now you should take the screenshot of this. Done?
Yes, sir.
Okay. Now you should do this. Take the screenshot of this also. Done?
Yes, sir.
Okay. Take this screenshot.